Imagine a world where your smartphone detects stress through your facial cues, or a robot identifies your joy just by analyzing your expression. This isn't science fiction. It's the cutting-edge field of emotion recognition, where machines learn to read human emotions. But how does this work? Let's explore a groundbreaking study that's redefining how AI understands our feelings. The challenge: facial expressions are incredibly complex. Every face is unique, and subtle shifts in a smile or a frown can carry different meanings. Traditional methods often fail to capture this variability. But here's the breakthrough. Researchers are using neural networks, computer systems modeled after the human brain, to decode these nuances. The team started with a dataset called CK+, which contains thousands of facial images showing people transitioning from neutral expressions to their strongest emotions. Think of it as a video of someone moving from calm to surprise. But here's the key innovation. Instead of analyzing the entire face, they focused on facial landmarks, specific points like the corners of the eyes, the tip of the nose, and the edges of the mouth. By tracking these points, they could quantify how faces change when we express different emotions. Imagine drawing a face. You'd mark the eyes, nose, and mouth. Now picture how those points shift when someone smiles or frowns. The researchers did something similar, but with a twist. They didn't just track positions. They measured how much each point moved between a neutral face and an emotional one. This created a detailed map of emotional changes. But here's where it gets really smart. To make sense of this data, they developed a new tool: facial landmark box plots. Think of it as a data dashboard that shows where most faces fall and highlights outliers, faces that don't fit the pattern. This helped clean their dataset by removing inconsistent examples that could confuse the AI. Then came the test: could a neural network outperform older methods? They compared two approaches. The first was a decision tree, a step-by-step system like a flowchart. The second was a neural network with advanced techniques: batch normalization, which stabilizes training by normalizing inputs, and GELU activations, a sophisticated function that lets the network learn faster. The results: the neural network dominated. While the decision tree achieved 80% accuracy, the neural network hit 48%, a near-perfect score. Why? It could spot subtle patterns, like how a slight eyebrow raise might signal surprise. This precision is a game-changer for real-world applications. So why does this matter? Better emotion recognition could transform tech. Imagine virtual assistants that adjust their tone based on your mood, or healthcare systems that detect early signs of anxiety. But here's a critical issue: AI isn't always fair. Let's talk about data bias. In this study, surprise made up 25% of the dataset, while contempt and fear were underrepresented, just 5.5% and 7.6%. This imbalance skews AI performance. It's like teaching a child to recognize dogs, but never showing them a cat. To tackle this, researchers analyzed facial landmarks again. They found that contempt had the most consistent expressions, 68.7% of landmarks tightly grouped, while fear had the most outliers, showing vast variability in how people express it. Think of it as a tidy room versus a chaotic one. They tested two models: neural networks, complex, high-accuracy systems, and random forests, a set of decision trees. The neural networks achieved nearly 98.5% accuracy, but simpler models were faster. It's a trade-off: high performance versus efficiency. What made neural networks so effective? They learned to detect subtle patterns in facial landmarks. For example, surprise had over 5,000 data points, making it easy to recognize. But fear remained tricky due to its messy, variable expressions. This research isn't just about numbers, it's about fairness. If AI is biased toward common emotions, it might miss critical signals like hidden fear. Future work could use data augmentation, adding synthetic data, or transfer learning, leveraging knowledge from other tasks to make AI more equitable. So next time you see AI recognizing emotions, remember, it's a work in progress. Scientists are refining these systems to be more accurate, fair, and human-like. Who knows? Maybe one day your phone will truly understand when you're stressed, or just incredibly surprised. Thanks for watching. If you want to dive deeper into how AI learns emotions, hit subscribe and let me know in the comments. What emotion do you think AI gets wrong?